Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was explaining the exercise questions which were there in the chapter 10 of 9th standard science subject. That was on work and energy. So in that video, I have covered questions 1 to 7. So in this particular video, I will cover the next questions which are there in this particular exercise. Now moving further, when we come to the question 8, here they have asked, does the transfer of energy take place when you push a huge rock and you fail to move it? So here also, when a person, for example, on a path, there is a big rock like this, and let's say a person is trying to move this particular rock. So he is applying enough amount of energy, whatever he has in his body, to move that rock. But this rock doesn't move. So this rock does not move, but still this person feels tired because he has put his complete energy in trying to push that rock. So in this particular case, whether work is done or not. So here work done is 0. So in this case also there is no displacement happening for this rock. So that's why work done is 0. But still the energy which this particular person is putting is getting converted as heat energy. So lot of heat energy is generated in that process. So that means the potential energy which he had in his body initially, so that energy he is spending as heat energy, but there is no work done. Here work done is 0. That means there is energy transformation happening, but there is no work done. So the amount of energy which he is putting on this rock is getting converted to heat energy. So this you can write in your own words. So coming to the 9th question, here a particular household has spent 250 units of energy. So here this particular household has spent 250 units of energy. Now you have to calculate the energy in joules. So always remember 1 unit means it is always equal to 1 kilowatt hour. So what is 1 kilowatt hour? So 1 kilowatt hour is always equal to 3.6 into 10 power 6 joules. So that means basically 1 unit of energy is equal to 3.6 into 10 power 6 joules. So that means here this particular household has spent 250 units of energy. So 250 units of energy is equal to 250 into 3.6 into 10 power 6 joules. So you will get 900 into 10 power 6 joules. So or you can write this as 9 into 10 power 8 joules. So in joules it is 9 into 10 power 8. So 9 into 10 power 8 joules of energy has been spent by this household. So coming to the 10th question, here there is an object. So let's say this is the object and it is raised to a height of 5 meter. So 5 meter height this particular object has been raised from the ground, and the mass of this object is equal to 40 kg. So here mass of the object is equal to 40 kg and this object is raised to 5 meter height from the ground. So now you have to calculate the potential energy gained by this object when it reached 5 meter height, and after that you have to calculate the kinetic energy when this object is falling down and when it reaches the halfway. So that means here this object is made to fall back, and when it reaches the halfway, that is equal to 2.5 meter. So at this particular position, what is the kinetic energy? So what is the kinetic energy when it has reached the halfway? So that kinetic energy you have to calculate before calculating that kinetic energy, you should calculate what is the potential energy at 5 meter height. So, and the mass of this object is 40 kg. So, first we will try to calculate potential energy of this object. So, potential energy formula is mgh. Instead of writing PE, I can write this as EP. So, EP is potential energy. So, EP is equal to mass is 40 kg, acceleration due to gravity is 9.8 meter per second square. Here they have not mentioned the acceleration due to gravity as 10. So you have to take 9.8 meter per second square as the acceleration due to gravity, and height at which this object is kept is 5 meter. So now 40 into 5, so 4 5s are 20, so 200 into 9.8 is there. So when you calculate 200 into 9.8, it is equal to 1960 joules. So this much amount of potential energy this object possesses when it is at 5 meter height from the ground, and the mass of this object is 40 kg. Now in the second case, you have to calculate what is the kinetic energy at halfway. So when this object is made to fall down, so when it reaches the halfway, that is somewhere around 2.5 meter above the ground. So at this point, what is the kinetic energy? So in order to calculate kinetic energy, you require velocity v. So velocity v is required, but here we don't know at what velocity this particular object is traveling at the halfway when it is dropped down from 5 meter height. So in order to calculate this velocity, you can use equations of motion. So if we use the third equation of motion, that is v square is equal to u square plus 2as. So in the place of a, I am taking plus g because the motion is along the gravitational force. So that's why I am taking plus g in the place of acceleration into s. So this is third equation of motion, where u is the initial velocity, and here initial velocity is 0 because we are just dropping from the 5 meter height. That object has been dropped from the 5 meter height. So that's why initially it was at rest. So that's why initial velocity is 0. So this particular term becomes 0. So v square is equal to 2gs will be remaining. So now v square is equal to 2 into acceleration due to gravity is 9.8 into what is the distance which it has traveled? It has traveled 2.5 meter because it is at the halfway. So from top also it is at 2.5 meter, from bottom also it is at 2.5 meter distance. So in the place of s, I can write 2.5 meter. So v square is equal to 2 into 9.8 into 2.5. We will get 49. So v is equal to square root of 49. Here velocity cannot be negative, hence we are only taking the positive value of the square root. So plus square root 49. So 7 into 7 is 49. So when you take square root of 49, you will get 7 meter per second as your answer. So now you have got 7 meter per second as your velocity. Using this you can calculate kinetic energy. So kinetic energy Ek at halfway, it is not the kinetic energy throughout the journey of that particular object from the 5 meter height to the ground, because always kinetic energy goes on increasing. So now here we are calculating kinetic energy at the halfway only, not at other positions. So at the halfway, the velocity is equal to 7 meter per second. Using that velocity, we are calculating kinetic energy at the halfway. So here Ek at the halfway, so I'll just write this as EKH, that is the halfway. So EKH is equal to half mv square. So now we can calculate this. EKH is equal to half. In the place of mass, we can take the mass of object, that is 40 kg, and in the place of velocity we can take 7, so 7 square. So half into 40 into 7 sevens are 49. So 2 ones are 2, 2 twos are 4, 0. So 20 into 49 will be remaining. So 49 into 2 is 98 and 1 0 will be there. So 980 joules is the kinetic energy at the halfway, and 1960 joules is the potential energy when it was at the top. So here potential energy at 5 meter high, we got that as 1960 joules, and kinetic energy at halfway we are getting as 980 joules. So in textbook, if you refer the answers, there they have given 2000 joules as answer for potential energy and 1000 joules as the answer for kinetic energy. What they have done is they have considered the acceleration due to gravity as 10 meter per second square. So if you calculate this potential energy and kinetic energy using 10 meter per second square as the acceleration due to gravity, then you will get 2000 joules and 1000 joules as your answer. But if you take the actual acceleration due to gravity, that is 9.8 meter per second square, then you will get potential energy as 1960 joules and kinetic energy at the halfway as 980 joules. But what I suggest is that you should always follow this particular method where you should consider 9.8 meter per second square, because in question they have not mentioned you should take 10 meter per second square as acceleration due to gravity. So that means here you should consider 9.8 meter per second square as the acceleration due to gravity, and if you consider 9.8 meter per second square as acceleration due to gravity, then you will get 1960 joules as the potential energy and 980 joules as the kinetic energy at halfway, and potential energy is at 5 meter height. So coming to the 11th question in this exercise, here they are asking what is the work done by force of gravity when a satellite is revolving around the earth. So now if earth is there like this, then a particular satellite is revolving around this earth like this. So now if you consider the displacement with respect to the earth's surface, that is the vertical displacement with respect to earth's surface, everywhere it is not getting displaced vertically towards earth's surface. So that means here vertical displacement, so here vertical displacement is almost zero in this particular case. So that means work done by force of gravity is equal to 0, because force of gravity acts vertically on the object. So vertical displacement by the satellite is 0 because it is following a constant circular path. So that's why force, so work done by force of gravity is 0 in this 11th question. Coming to the 12th question in this exercise, here they have asked, can there be displacement even when there is no force acting on an object? So according to Newton's first law, if there is no external force acting on an object, so if an object is already traveling in an uniform speed, so if an object is traveling at uniform speed, then there is displacement happening, but there is no external force acting on it. So an object can be at rest or the same object can be at uniform speed if there is no external force acting on this object. So any object which is moving at uniform speed or that object when it is at rest, if there is no external force acting on that object, then that object continues to be in that particular state of motion. So when I have explained about Newton's laws of motion in my previous videos, there you can get answer for this particular question. So if you want to understand Newton's laws of motion, you can refer my previous videos. According to Newton's first law, when an object is traveling at uniform speed, it continues to be in uniform speed if there is no external force acting on it. So now if I consider the case of an object where the object is moving at uniform speed, then even though there is absence of force, still this object continues to be in uniform speed according to Newton's first law. So that means there is displacement of this object when it is traveling at certain speed. So uniform speed, if an object is traveling, means at every instant of time there is displacement happening, because speed is nothing but displacement by time. That means at every instant of time there is certain displacement happening. So that's why here displacement is possible. So answer is yes. So answer is yes for this particular 12th question, and explanation is that you can refer Newton's first law of motion, where if an object is at uniform speed, it maintains the uniform speed if there is no external force acting on that object. So hence there is absence of force on this object, hence this object continues to be in uniform speed. So that's why in this particular case there is displacement happening even though there is no external force acting on this object. Coming to the 13th question, here a person is holding a bundle of haze in his hands. So a person is holding some objects in his hands for longer time, and in this case person gets tired after a while by holding those objects, those haze in his hands for longer time. So here whether a person has done some work or not, you have to answer. So here work done by this person is equal to 0, because even though he is spending some energy in holding those objects in his hands, still there is no displacement happening. So even though he is applying certain amount of force in order to hold them in his hands, still there is no displacement happening, hence work done in this case is 0. Coming to the 14th question, here a particular heater is rated 1500 watt power. So that means they have given power of this heater that is equal to 1500 watt, and this particular heater is being used for 10 hours. So time is equal to 10 hours. Now you have to calculate how much energy has been spent by this heater when it is running for 10 hours, and the power rating of this heater is 1500 watt. So that means basically you have to calculate energy that is equal to power by time, because power is nothing but work done by time and work done is nothing but energy. So power can be known as amount of potential energy divided by time. So here in order to calculate that energy, that is equal to power into time. So you are bringing this time to LHS, so that becomes power into time. So in order to calculate energy, you can multiply power with time. So here power is 1500 watt into 10 hours. So that means this is equal to 15,000 watt hours. Now you have to convert this to joules. So in order to convert that to joules, so always remember 1 watt second is equal to 1 joule, or 1 watt is equal to 1 joule per second. So because 1 watt is equal to 1 joule per second, 1 watt second can be known as 1 joule. But here we are getting answer in watt hour. So energy is equal to 15,000 watt hours. So now you have got energy as 15,000 watt hours. So now if this particular watt hours is converted to watt seconds, so directly you can put joules in the place of watt seconds. So in order to convert this watt hours to watt seconds, this hours you can convert to second. So always remember 1 hour is equal to 3600 seconds. So that means in the place of hour I can put 3600 seconds. So that means energy is equal to 15,000 watt into 3600 seconds. So now if you do 15,000, so I'll just write this one more time. So 15,000 into 3600 watt second is the energy. 54 followed by 6 zeros watt second. So in the place of writing 6 zeros, I can write 10 power 6, or I can write 5.4 into 10 power 7 watt second. In the place of watt second, I can write joules. So that means energy is equal to, so in the place of watt second, I have written joules, this particular joules. In the place of watt second, I have written joules. So 54 followed by 6 zeros, I can write that as 5.4 into 10 power 7. So 5.4 into 10 power 7 joules of energy has been consumed. So this is all there in this particular video. The further questions which are there in this exercise I will be teaching in my next video. So until then, if you want to learn more physics, chemistry and mathematics, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel.